Welcome to the 2022 Smoke Management Program training session held by Western Weather Group. Thank you all very much for being here on time. Let's just go ahead and get right into it. So what we're going to do today is go over the program goals and background. We'll go over some more recent history with the 2021 burn summary, as well as some updates and sort of a future look at this season. After that, we'll go through the procedures of how the fall burn program works, as well as what the daily schedule will look like once we start that. From there, we'll have a few notes about prescribed burning. That will wrap up my first part of my presentation, this PowerPoint. And then we're going to have Jason Branz from the Air Resources Board give a really nice presentation on weather basics. So if there's any terms you're unfamiliar with that I might throw around, this will clarify all of that. It just offers a really good foundation if you haven't heard these terms before, and a really good reminder for everybody else. After Jason's presentation, I'll jump back on and I'll do a live demonstration of how to use the Western Weather Group website dashboard, as well as how to submit program files, or the burn acreage files as they're also called. After that, we should have plenty of time for discussion and still be done by noon at the latest is my goal. All right, so what are the goals of the fall burn program? First and foremost, the protection of air quality and public health and public safety. Since we're going to be putting smoke in the air, we want to make sure we do it responsibly. And with that, we want to have an effective management of daily agricultural and burning operations. So we want to be able to burn as much as possible with the minimum amount of smoke impacts. So whenever I tell people about rice burning in the fall, the first question they always ask is, why does it need to happen in the first place? It seems everyone's had enough of fire, so why do we need more of it? Well, burning rice straw is the most effective way to eradicate disease after harvest in the fall. Another way to do this is flooding fields via water. However, given drought conditions and the cost of water, it's burning the rice straw is definitely the most efficient way to do it, and in many cases the only way to do it. And with this, we do have the smoke pollution from these burns, and if completely unregulated, can really lead to unhealthy air quality through the Sacramento Valley air basin. This program exists to allow rice burning to take place responsibly. So a bit of history with how this program got started. Some burn programs existed in the Valley Air Basin through the 1980s, but the program as we know it really started to take shape in 1991 with the Connolly-Arias-Chandler Rice Straw Burning Reduction Act. So what this did is it took the sort of less regulated burn amounts that were taking place and progressively phased down how much rice could be burned through the 90s, with less allowed each year. By 2001, we reached the current standards that we currently use today, which involves the Conditional Rice Straw Burning Permit Program. What this does is it verifies that there's a sufficient level of disease that needs to be burned away in order for burning to take place. The standard that we use nowadays is 25% of the total basin planted acres, or 125,000 acres, whichever is less, and that's how much we're allowed to burn through this program. So here's a chart showing how that phase down took place. As we can see at the top of the chart, in 92, there was about 402,000 acres planted and about 303,000 acres allowed to be burned. So that was about 90% of the planted acres. Then it went down to 80%, 70%, et cetera, stalled around 200,000 acres allowed from 98 to the year 2000. And then from there, in 2001, we got to that 25%, or 125,000 acres, that we still use today. So after that, we needed to find a way to clarify or to qualify the level of disease that was taking place within the air basin. So in 2003, the county ag commissioners would use random sampling and statistical analysis of rice fields to find how prevalent disease was every single year. So that happened yearly for up until 2009, when UC Davis conducted an evaluation of disease prevalence in the air basin. And this was switched from every year to every 5 years, with the latest evaluation taking place in 2019 and still being valid through today. So with the current rice burn program that we use, the UC Davis evaluation is the required one to permit burning within a county. So for a moment, we can take a look at some of the different diseases that are considered in that UC Davis disease prevalence study that takes place every 5 years. The first one is stem rot. That's the top picture here, sort of what that looks like zoomed in. In that study, it was found in 100% of surveyed fields with an average infection rate of 65% valley-wide. It usually takes place in low potassium soil. Another disease that's looked at is aggregate sheath spot, which is the bottom picture there. It was found in 94% of surveyed fields, averaging 35% valley-wide, and it's more common in nitrogen excessive soil. The requirement for either is only 15%, so obviously meeting those requirements to permit burning by a wide margin. Another disease that's considered in the study is rice blast. It was only found in 9% of fields and 7% valley-wide. Nearly all the cases were in Glenn County, with a few in Butte and Colusa. The requirement for this one is only 1.8%, so still well above the margin for needing to burn. Here's a chart showing the details of that study. So you can see all the different percentages of disease prevalence through each county. I'll just let that sit up there for a second if you want to glance over it. Okay, moving on from the disease specifics, we can talk a little bit more about recent smoke management program history. We can do this with two fairly depressing graphs. The first here on the left is courtesy of CAL FIRE. This is the chart showing the 20 largest California wildfires in state history. So we can see from that all but 3 of the top 20 largest wildfires have taken place since the year 2000, and over half of them have taken place since the year 2020. So just a ridiculous uptick in immense wildfire acreage and severe smoke impact through the Valley Air Basin. So that really complicates our operations and just no good in general. This particular chart was even generated before the Dixie Fire was completely contained. That actually ended up getting a little bit closer to 956,000, I believe. I have the exact number on the next slide. Another story of the modern goings-on in the fall burn program is ongoing drought conditions. This is courtesy of NOAA and the Drought Institute, the Drought Mitigation Center, rather. You can see that pretty much all of the air basin from Shasta County all the way down to Sacramento County is in extreme drought, so really not a lot of water to go with. And we can see this reflected in our planted acres when we talk about what we were allocated for this season. So here's a more in-depth look. It took me a little bit to crunch these numbers, but let's go through this chart that I have here at the bottom. So starting with the columns, we have on the left, we have the total acreage that takes place, every average or burn acreage for every year. Going to the right, we have the average complaints per year, how long the fall burn season lasts each year on average. And the next 6 columns are how often we get different types of burn days. I'll go into all the details on these in a moment, but for now you can just focus on the permissive burn days, sort of in the middle of the chart, the restricted fields days over to the right, and the no burn days a little bit further to the right. And then all the way on the right we have the meteorological numbers there for daily PM 2.5 on average, which is your air quality. Higher is worse air quality, and also a seasonal rainfall through the fall burn season. So looking at the rows, we have the all-time averages, which are pretty self-explanatory, just averaging everything from 2002 through 2021. I am missing the 2021 data, or sorry, 2001 data if you happen to have that. So the story really starts for the first 10 years here, in that second row, where we see we have some pretty high averages for total burn acreage and rice acreage. A little bit higher on the complaints as well. And then overall, very high percentage of permissive burn days right in the center of the graph there. Now, if we go to the latest 10 or 11 years, we can see a significant reduction in how much acreage has been able to be burned. So that's pretty much half compared to the first 10 years of the program. And with that, we can also see a pretty notable drop in the permissive burn days and a rise in restricted fields days and no burn days. So the days in which we can burn, we're not allowed to burn anything for a variety of reasons. The latest 5 years have really accelerated this trend where we can see another sharp drop in how much acreage we've been able to burn and how many permissive burn days we've lost compared to how many more restricted fields and no burn days that we've gained. Really interestingly, if we look at the PM 2.5, we can see that even despite how little rice acreage you've been able to burn, our PM 2.5 value has actually gone up on average in the last 5 years compared to the first 10 years of the program. Also, noticeably, the average rainfall per season is dramatically lower in the last 5 years, just sort of highlighting the extreme drought conditions that we've been experiencing. So if I were to summarize all this, I would say that for the latest history of the fall burn program, we've had more challenging meteorological conditions to contend with. We've had a lot of abnormally dry and windy autumns, which leads to high fire danger and extreme fire behavior. So controlled burns that we want to do become difficult and or impossible to conduct, while any wildfires that manage to get started produce immense amount of smoke and exhibit extreme fire behavior. With that, we have really low rainfall to boot, worsening our drought conditions. So that was a bit depressing. Sorry about that. We can talk about the 2021 recap as well. It was another intense summer fire season. We had the Dixie Fire, which became California's largest single origin wildfire in state history. This means that it started from one place and spread out from there versus being a complex fire and starting from a variety of places and sort of burning into each other and burning together. So this almost burned 1 million acres just to the east of the air basin. Despite this insane amount of acres that were burned, most of the smoke did remain out of the valley due to really persistent westerly winds. We didn't escape smoke entirely, however. We did have some east wind events that brought a lot of smoke into the valley, as well as a few other wildfires that complicated burn operations on some days. The hallmark event of the 2021 season was definitely the historic atmospheric river rain event, though. With this, we had 4 to 8 inches of rain that fell just within 2 days, and this ended up being the highest seasonal rainfall recorded since 2001 by nearly an inch. And that also sort of highlights, if I go back to the past slide with the average rainfall, that insane amount of rain was included in this average that's still dramatically lower than the earlier years of the burn program and than the average total time within the burn program. So even this crazy amount of rain didn't help the average that much. So what all this rain did is it flooded quite a few of the fields. In fact, 97% of all the rice was burned through the season before this event, which just happened on October 24th. So really only about a month of burning. And then the fields were just too wet to burn for the rest of the season. Some orchard burnings were able to take place, but rice burning was pretty much done right after that storm. For some more minor statistics, we had 4 less complaints than 2020. We only burned 700 less acres. So this ended up being the third lowest burn acreage on record after 2020 and 2018, respectively. On here, we have a few charts as well that I'll sort of leave up on here. They're just some details about complaints and also burn acreage per county and also per crop. So I'll just leave that up for a little bit to take a look. But you can really see that insane total rainfall of 6.9 inches, just way higher than anything we've recorded in the since the early 2000s. Okay, so let's go ahead and look at sort of the weather outlook for this coming season. We are in a La Nina advisory. You'll recall that we were in a La Nina last year as well. This is a bit of a stronger La Nina than last year, however, so it'll be slightly different. Overall, we do have some fairly similar outlooks available to us, though we have a slightly higher chance for early season rain, although the models are drier than last year. We have also a higher chance for inside slider type storms with a La Nina setup. We'll get into more details later, but those are basically very dry and very windy storms, so they can generate severe fire weather conditions that really complicate controlled burning operations. Another thing that seems likely are above average temperatures. This is especially true for about the middle of this week through the middle of next week at least. So here is our allowable burn acreage for 2022. We can see that we have 258,446 planted acres. And this seems like a lot if you're unfamiliar with the numbers, but this is about half of what we had last year. Last year we had about 210,000 acres more than this, so way up in the 400s. And what this has yielded from the 25% rule, we have a burn limit of 64,612 acres, which is very, very low, about half of what it was last year. For some other information, we're planning on commencing the program on Thursday, September 15th, and continuing up to or through November 30th. The rice burn hours are from 10 a.m. to 3 p.m. with all flames out by 4 p.m. The orchard crop burn hours are from 8:30 a.m. to 5 p.m. or 1 hour before sunset, whichever occurs first, since you don't want to be burning at night when things get stable. The program test days will be taking place on the 13th and 14th. On these days, we'll be issuing test forecasts to make sure that everyone who wants them is getting them okay, and we'll also be receiving test file submissions from burn districts to make sure that everyone's familiar with how to send in burn acreage information. All right, so now we can go through the procedures of how we want to conduct the fall burn program. It's all about conservative burn management, which means that when conditions are marginal or worse, significantly less acreage should be allocated than if conditions are good or ideal. If there's any risk that we might smoke someone out, we want to allocate less acreage and be really careful about how we do that. Some example of challenging conditions are really stagnant or stable air masses where smoke will not want to rise and it will not want to disperse very well either, or strong north winds that will make controlling fires difficult and will also push smoke southward into more highly populated areas like Sacramento and the Bay Area. So for some things to consider when allocating acreage are the field conditions. Wet rice will not burn efficiently and put up a lot more smoke versus dry rice. The harvest technique also determines how quickly fields are able to dry out and be ready to burn. Spatial distribution of fires is important as well. You don't want to put up two massive fires right next to each other if the conditions will not permit that going well. And with that, you'll have to really consider the meteorological conditions, which include stability, or how well your smoke is going to rise and disperse, your winds of sort of where that smoke is going to be pushed, and also the air quality to start with, since we won't want to put more smoke in the air if the air quality is already poor. So some more information on atmospheric conditions. The way we talk about atmospheric stability is through inversions. So in our normal atmosphere, and Jason's going to talk about this in even more depth, but in our normal atmosphere, we're going to lose temperature with height. So the higher we go in the atmosphere, it's going to get colder. When we're in an inversion, that trend is inverted, meaning that we get hotter as we go higher. What that does is your hot air will not want to rise. It's going to stay near the surface and have a lot of trouble dispersing. With that, we also have the mixing layer depth, which describes how high your smoke plume is going to be able to rise before it starts to stagnate and potentially want to come back down. We have our wind speed and direction, which is pretty self-explanatory. Where is our wind blowing from? And so what is the downwind population potentially? Who might be affected? Also wind speed, are things going to be so windy that we have to worry about fumigation and smoke being unable to rise and just going horizontally into a population potentially, or are fire conditions going to be such that it might be difficult to control some fires? Moisture is very important. I want to consider relative humidity, the presence of dew, especially the fuel moisture, or how much moisture is in what we want to burn, since the wetter it is, the less efficiently it's going to burn. Also, cloud coverage is important for that and sort of ties back into stability. If it's really cloudy, that's going to impede our lift and also prevent things from drying out as well. And of course, air quality makes a lot of sense. We'll need to keep a close eye on air quality at all times to make sure that if the air quality is already not doing well, then we really can't afford to put more smoke in the air. This is measured by PM 2.5, or particulate matter that is 2.5 micrometers across. This particular metric is used because this diameter of particle has been found to be most harmful to lung tissue. So it's a health consideration. Airport visibilities are also concerned, so if it's too smoky to see stuff, that's also a bad indicator. So all of this information, that atmospheric condition information, gets fed into the allocation equation. So you certainly don't have to memorize this or understand exactly everything that's going on, but you can see that all of these variables that go in there are what we just talked about: the stability, the 500 millibar heights, which is sort of a measure of upper atmospheric stability, wind speed, and also PM 2.5 concentrations. So all of it's considered when we're figuring out how much acreage can be allocated to start with. From there, that theoretical number that the equation spits out is then fine-tuned a bit more with the county acreage distribution equation. So this is weighed a little bit more towards areas that have more ready acres, or more acres that are ready to burn, and also heavily considers local air quality. So if perhaps the air quality is really poor in Butte County versus maybe it's better in Colusa County, maybe Colusa would have a more weighted factor to it versus Butte, which would be asked to burn less due to poor air quality. So with that, we have our acreage that was initially allocated. Now we need to sort of communicate this in a way, and what we do this is we declare different types of burn days. So there's 6 different types, and I'll be going through each of these in more detail. A quick summary, though, is that regular permissive burn days are what we want. We have a minimum of 200 acres per county, and conditions are overall good. However, that doesn't mean they're perfect everywhere. We have wet days, which means we can't burn quite as much, and we need to perform the crackle test to make sure that rice is dry enough to burn in some cases. And also on the good side of things, we have early and extended burn days, where we're able to extend the burn hours either early or late because of favorable conditions. On the less good side of things, we have restricted fields days, pruning only days, and no burn days, in which acreage is significantly reduced or taken out altogether due to poor weather conditions. So let's take a look at this criteria chart here to sort of visualize what sort of conditions result in what type of days. So here we have our less acreage days, and we'll sort of start from the bottom and work our way to the top. So on the right, we can see the burn day declaration. On the left, we can see what conditions resulted in that. So we can see we have two different ways to get restricted fields days. We can either have a basin average north wind of greater than or equal to 15 miles per hour, so a lot of smoke potentially ending up in densely populated areas to the south, or we could have really stable conditions with a strong inversion, with poor air quality to start with, and with very weak winds. So that's how we get a restricted field day. For prunings only, it's very similar to a restricted field day. However, the air quality is slightly worse. So no rice can be, or field crops can be burned that day. It can only be orchard prunings because they burn hotter. We'll talk about that a little bit more in just a second. There's three different ways to get no burn days in which no burning can take place whatsoever except for pre-approved prescribed burns. We can either have a basin average north wind of greater than or equal to 20 miles per hour, so really quite breezy out of the north and lots of smoke potentially ending up in densely populated areas to the south, or we can have very high stability and or poor air quality in either an average throughout the basin or in 3 or more sites via some slightly different numbers. So let's get into some more details about each type of burn day. So here's our regular burn days, hopefully what we'll be ending up with the most this season. This is declared when that acreage allocation spits out at least 2,000 acres, and there's no reason to declare a prunings only or restricted fields day. The minimum allocation per district is 200 acres and can be more if conditions merit. We'll try to get as many acres as we believe the air basin can handle. So even though it's a regular permissive burn day and overall good, that means good conditions, it doesn't mean that conditions are exactly perfect everywhere or the burning can take place carelessly. It's still very important to check the PM2.5 and ozone levels and forecasts and the meteorological conditions in general. So you'll really want to still make sure that you're reading the forecasts, you know what the wind's doing, and just have a good understanding of what's going on before you burn. For wet days, this takes place when we get some rainfall. As I mentioned earlier, fuels do not burn as efficiently if there's moisture involved. So what happens here is that if we meet a criteria, a crackle test has to be performed on rice straw in order for it to be burned. So if it passes the crackle test, you can burn it, and if it does not, then you may not burn that rice. So to understand that qualification, we can look to the table here on the right. So what this does is it tells you how much rainfall has taken place and also within how many days that heavy rainfall has taken place. So if we start from the bottom, we can see if you get more than 18/100ths of an inch or greater in one day, then that's automatically a wet day and you have to do the crackle test or you can't burn that rice. We can also see in that middle column the highest rainfall in the previous 3 days. So if you get a lot of rain on one day, this tries to factor in that it's still going to take a while to dry out and you're really going to want to perform that crackle test, or rather you have to perform that crackle test in order to burn it. So for example, with that crazy atmospheric river event we had last season, we had quite a few wet days. We had that massive amount of rainfall that guaranteed at least a few wet days automatically, and then a few lighter rain events that kept adding on to that total. So the wet days just kept on coming. So talking a little bit more about the crackle test, this is, if it's a wet day, you have to do this in order to burn your rice straw. So what you do is you take a random sample of straw from around the field, such as under the mat, center of the mat, from different areas, and with that handful, you bend it sharply, and if it crackles when bent, then it passes. If it doesn't make much noise or just sort of bends over limply, then it is too wet to burn, and you may not burn it if it's a wet day. And even if it's not technically a wet day, it's a really bad idea to burn that straw if it's too wet. All right, with that, we can talk about drying times as well. So This is affected by how the rice was harvested. So depending on how that rice was harvested, it can take between 3 to upwards of 10 days to dry out properly on average. So for example, spread rice usually takes around 3 days to dry off um, properly, unless it passes a crackle test earlier, versus road rice, where it's all piled up on top of each other in one direction, can take a lot closer to 10 days to dry off properly. And chopped rice, where there's just little bits stacked on top of each other pretty thickly, that has to be reported by growers to the air districts because of how much moisture it maintains and how poorly it's going to want to burn if it does happen to get rained on. Next, we have restricted field stays. So this, as we saw earlier, is due to breezy north winds or poor air quality and high stability. Here, only 50 acres of field crop residue or rice straw may be burned, but you can still burn up to your given allocation of other things, or namely orchard prunings. So 50 acres of your rice straw and potentially up to the rest of your allocation of orchard prunings. So on restricted field stays, because of the poor conditions, regardless of what you're burning, you're going to really want to place those burns appropriately. Dispersion will be limited. It's definitely better to burn later in the burn hours as that inversion mixes out and we have a maximum amount of lift. Pruning's only days, if you recall, it was just slightly worse air quality conditions than at restricted field stays. Here, no field crops such as rice straw can be burned. Only orchard prunings are allowed to be burned, and this is because pruning piles tend to burn a lot hotter, allowing smoke to rise higher and disperse more effectively. Next, we have our least favorite, which is no burn days, in which all crop residue burning is prohibited, including those orchard prunings. Nothing can be burned unless it was a previously approved prescribed burn. And even then, you're going to have some pretty challenging conditions for those prescribed burns to take place. So the best and unfortunately also rarest burn days are the early and extended burn days, where we have really good dispersion conditions and we can extend those hours a bit further. So maybe if we have a storm coming in, we have some good south winds, so pushing smoke generally away from the most populated areas, although we'll still have to keep in mind who's downwind of wherever you're burning. We have increased lift and mixing, but there's no rain yet, so it's still dry. So with those conditions, we can extend the burn hours past what they usually are and hopefully get some extra acreage in before the storm moves in. You'll see these notifications made pretty clearly from the Western Weather Group forecasts. So now that we've talked about all the different burn days that we can see, we'll sort of talk about a day in the life of the fall burn program, sort of how all of the operations take place. So this all starts pretty early in the morning. At 5:45, we have our initial Sacramento Valley forecasts that's published to the dashboard, which I'll be showing off later. This isn't emailed out, but you can click on there if you're up early and get a good idea of how the weather conditions are to start with. At 7:30 a.m., the Smoke Management Program Coordinator and the forecaster from Western Weather Group will communicate with ARB to make sure our forecasts are in line and sort of work out the fine details. From 7:45 to 8 a.m., the air districts will publish their acreage files of what they burned the previous day. Around 8 o'clock, we'll have the burn day status, either burn or no burn, published. 9 a.m., we have the main forecast file that's going to come out with all the detailed acreage allocation. At 9:30, we have our conference call, which is very important. We'll talk a lot about when we get there. And around 10 to 11 a.m., we have our 11 a.m. forecast, which just has some updated forecast information if necessary, as well as potentially any notifications of extended burn hours. Let's talk about each of these steps in more detail. First, we have that initial Sacramento Valley forecast, which is issued around 5:45 in the morning. This is a very broad forecast overview for the whole valley and doesn't necessarily focus on smoke management program operations. Nonetheless, it's still a very good first look at what the weather's doing up through 7 days, and even an outlook out to 10 days, and a general forecast discussion, just to sort of start getting your bearings as the day starts. At 8 a.m., we have our burn day status. So right at the top, you'll see if it's either burn or no burn. Notice that no acreage allocation has been set yet. That takes place with the 9 a.m. file. So this just lets you know burn or no burn, and also provides some preliminary air quality data to see how the air basin is doing. So then we can see that given in PM 2.5 levels per these reporting stations, the BAMs or beta attenuation monitors that are placed throughout the valley. So after ARB talks with Western weather forecasters, we have that program file submission. So this is when the air districts will submit to Western weather whatever they burned yesterday, just so we can keep a really good track of everything that's being burned. It's really a good idea to submit these by 8 a.m. I'll be giving a detailed how-to and real-time presentation if you're unfamiliar with how to perform this after Jason's presentation. But for now, just know that this is the information about what was burned the previous day. It's really good to get it in by 8 a.m. so we can get things rolling just as fast as possible. So in addition to the how-to that I'll be doing, there is also a YouTube tutorial that I made. The fastest way to find that is just looking up Western Weather Group on YouTube. You can find the how to submit SMP burn files video from there. Okay, so now we have the main event of the day, the 9 a.m. file. This is several pages long, so I'll be going through each page just to sort of talk about what's on there without going into way too much detail. So this is the first page. We try to get it out as early as possible. Before 9 is awesome if we can do it. Getting the program files in as early as possible helps with that. Right at the top, we have our starting atmospheric conditions. We can see our PM 2.5, our atmospheric stability, how strong our inversion is, etc. And below that, we have some comments of sort of whatever the coordinator, most likely be me most days, sort of highlighting what to watch for that day, as well as what the official acreage allocation is per county or air district, as well as some complaint history and yesterday's burn information, as well as a brief season-to-date summary of both complaints and burn acreage as well. So also important to note here, so this is where the official allocation takes place, so do not authorize any field burning until you have your allocation with this 9 a.m. file. On page 2, we have our forecast discussion. This adds on to that earlier, more general forecast that you may have seen at 5:45 in the morning. This also goes into more detail about the surface winds and the transport winds taking place. Below that, we have our measures of stability, which is mainly the Sutter Buttes to Pennington version. We use these locations because Sutter Buttes Station and the Pennington Station are very close to each other horizontally. However, they're about 2,000 feet apart as far as elevation, so they're a great way to see how your atmosphere is warming up or cooling off as you go higher. So on the right of the current conditions, as well as how it was yesterday, we have our forecast for what we think the lapse rate, or how cold it will be from the surface to aloft later in the day, 2 p.m. when most burn operations will be going. We're hoping for around -8 or less, with colder being better. Below that, we have our stability discussion and burn status outlook. The stability discussion talks just in words what we're thinking for how stable the atmosphere will be, as well as how high the mixing heights will be. Also talk about the cautionary notes again, just reiterating what we think will be the riskiest parts of the day. And the burn day status outlook talks about what we think the next, or what tomorrow and maybe the next day will be without officially declaring anything. So if it looks like conditions will continue, for example, here we had a restricted fields day on the day of the forecast. If the conditions persist, it will probably be another restricted fields day, but it's not completely official yet until tomorrow's 9 a.m. file. On the right, we have the zone ventilation ratings, which is a measure in number from 1 to 5 of how good we think the dispersion is going to be, with 1 being the worst. In more detail, we can see that 1 would equate something like considerable impact in the region regardless of the placement of fires, meaning very poor conditions for burning. It's really not a good idea to burn from what we can see. We can, from 2 to 3, we can see considerable or some impact if caution is not used. These are going to be the values that you're going to see most often, meaning that you're really going to have to take care of where you're burning and what you're burning. Because if you don't, there's a chance that you might smoke someone out and get a lot of complaints and cause some air quality issues. 4 and 5 are really nice to see, but they are a little bit more rare, unfortunately. 4 is really about as good as it gets. When we get to 5, where it's minimal or no impact in the region, unfortunately, it's probably already raining, and we already talked about how moisture can complicate your burn operations. So if you see a 4, that's really about as good as it gets most days, and that's going to be some much better ventilation. All right, on page 3 we have the ARB forecast. This comes from the Air Resources Board. So this talks about some more atmospheric conditions at the top, as well as some more air quality data here in the middle, as well as some history on that air quality data. Below that is the forecast notes as well. So we can see in writing sort of what they're thinking. You'll find that these discussions are oftentimes very similar to the Western weather discussions because we're both coordinating with each other, making sure that we're getting out the best possible forecast for the operations. So we have our cautionary comments for the day, the 24-hour outlook, just like the burn day outlook, as well as some stability notes and the wind forecast at the bottom. On page 4, we have our 3-day complaint history. We're going to want to keep those close to 0 as we can. Well, obviously 0 if we can. We have our confirmed file receipts there. Below that, with the X meaning we haven't gotten your burn acreage file yet, and the receipts file being self-explanatory. So if you see an X next to your county's name on the 9 a.m. file, you really want to make sure that you get those files into us as soon as possible and try to get it in a little bit earlier the next day. We can also start to see at the bottom of the page some burn acreage information. This is by zone per county. So that's all added up there in great detail. And the next page goes into even more detail about burn acreage. It does it by county again, as well as by crops, as well as the season to date values for both by county zone as well as by crop. On the 6th page, there's also a 2-day air quality summary again, so just some slightly updated air quality information, as well as an airplane sounding that was taken from Red Bluff. Jason will go into some more detail on how to read these, but in general, we have temperature here on the bottom. We have height as our y-axis, and we want to see our temperature decreasing with height, meaning that we do not have an inversion. On this particular example here, we see we do have an inversion. As we go higher in the atmosphere, the temperature does increase, which means it is stable. All right, so after the 9 a.m. file is out, we have the 9:30 a.m. conference call. So this is hosted by the Western Weather Group forecaster and or the coordinator. So every district who plans to allocate acreage is strongly encouraged to join. This promotes good coordination of burn placement among districts and also gives everyone who's burning an opportunity to directly ask a Western Weather Group meteorologist some questions and about their specific zone. So if you're burning in your zone 1 and want to know exactly what the winds are going to be like around the time you want to burn, we can do our best to look at that and also visually show that data via Microsoft Teams that we're using now to really help visualize how the burn's going to go and give the best forecast we can. It's really there to help coordinate between our districts and also answer as many detailed meteorological questions as we can. The last file you'll see from us is the 11 a.m. update. 9 times out of 10, it is pretty much exactly the same as the 9 a.m. file. However, sometimes there are some changes that need to happen in the forecast. If this is the case, you'll see this emailed out with all the changes highlighted. And well, this is also another place that we will highlight if there's going to be some burn or some extended burn hours. So yet another place to see that. So we'll always have this available on the dashboard to view online, but we'll only email it out if there's actually any noteworthy changes to the forecast or something exciting happening tomorrow. So to summarize for your decision making, carefully read all the program files and forecasts. You'll really want to participate in the 9:30 conference call to work with fellow air districts and the meteorologist. If you're planning on burning fields near district borders, you'll especially want to be in that conference to make sure everyone knows what's going on through the valley. You'll always want to be paying attention to the current weather conditions, especially the winds, inversion, and air quality. A lot of that can be viewed on the Western Weather Group dashboard. You'll always want to have well-spaced burns, both spatially and temporally, meaning you can space them out throughout your burn zone as best as possible, and also you can stagger the ignition times. So you can burn one field a little bit earlier, perhaps burn your higher risk fields later in the day when your lift is going to be highest. If conditions are poor, you'll really want to authorize only small fires in remote areas. So with all of that acreage allocation that comes out in the 9 a.m. file, if conditions are good, it's a good idea to ask for additional acreage. So say it's a normal burn day, you get issued 200 acres, but everything is going really well and you'd like to get some more burns done. What you can do is you can call the office, and I'll have all that contact information readily available at the end of this presentation, and definitely if you ask. You can call the office and ask for more acreage. So here's what to do if you want some more acreage on top of what you've already been allocated. So what you'll want to do is definitely be able to describe what the field conditions are like. That's what the fuel that you want to burn is like, making sure that it's dry enough and ready to burn, as well as what the weather is doing at that specific location. The absolute most important thing to mention when you're requesting additional acreage is how your current burns are going. Because if you call in and say the current burns are going great, we're seeing them go this way, and based on the forecast, seems like it's going to keep doing that, that's really strong in your favor of getting those extra acres. No problems at all. Obviously, we'll want to consider if any complaints have been received, since we won't want to put anything else in the air if things are starting to not work out exactly as planned. So yeah, whenever you want to know that additional or want those additional acreage, just be ready to prove that you have a really good understanding of how the burns are going and what the conditions are at the proposed additional burn. One really cool way to do that is use these alert wildfire webcams. I'll also show those off in my dashboard explanation, since we have a link on there, since they have really good views throughout the valley and you can see how the smoke plumes are behaving in real time. So some ignition patterns that are commonly used in the rice burn program. one I hear about most often is the strip heading fire, where we have multiple lanes of fire that are laid down perpendicular to the wind. What this does is the lines of fire will burn into each other as the wind direction is burning perpendicular to them, and this will increase the field temperature, yielding better lift, and also reduces the burn time, so you can get more done quickly before perhaps things turn more stable later in the burn hours. There's also a more controlled, slower way to burn things is with a backline, a backing fire. You start your fire at your backline and it burns into the wind a lot more slowly. But if you have less to burn and need to do it in a much more controlled fashion, then this can be a slower way to monitor things. With that, we can transition into talking a bit about prescribed burning. So Western Weather Group isn't directly involved with the approval process of prescribed burning, but when we're here in the smoke management program, or in the intensive fall burn season, rather, there's a few important things to keep in mind. So for some basics, you'll need to submit a smoke management plan for that prescribed burn and receive approval for it. You'll need to request that authorization to burn no later than the afternoon prior to the requested burn day. You'll really need to maintain communication with the approving air district and report burn status along with the acres burned upon its conclusion. So for the special notes to consider during the intensive fall burn season, it really helps us out if you can notify the coordinator within or at least 1 day prior to ignition whenever possible, just so we know everything that's going on. The district should be able to, or should approve the burn through the PFERS website, so burn information can be displayed on the PFERS maps. If there's any updates to that, I think Jason will be able to go through that, since I know there's been some updates. And then very importantly, if burning is conducted at or below the daily variable elevation as well as 2,000 feet, then the proposed acreage is considered part of the local acreage distribution. So if you have a 50-acre prescribed burn that's taking place below the daily variable elevation and 2,000 feet, then that will actually come out of the acreage allocation. That's important to keep in mind during the intensive fall burn season. All right, so in summary of everything that I've talked about here, our burn hours are from 10 a.m. to 3 p.m. with all flames out by 4 p.m. Our program test days are going to be on the 13th and 14th, and you'll receive plenty of emails from me prefacing that and how that's going to take place. Please do submit your program files, your acreage files by 8 a.m. so that we can keep an accurate tally in real time. You really want to read that 9 a.m. file carefully before making decisions and participate in the 9:30 conference call. You'll want to distribute your acreage allocations as spatially and temporally as possible, and always be watching field conditions and updated weather conditions. And to add on, if you don't have access to the Western Weather Group database dashboard, or you're not signed up to receive the Western Weather Group forecasts, definitely let me know so we can get all that squared away. You can put it in the chat, or we can just talk about it after everything is concluded here. Okay, well, that's everything that I have to talk about. I'll open it up if there's any questions now.
Yeah, a lot of this is probably going to be review for most folks on this call, especially if you've attended our weather talks that we've been doing once a month here since, I think, April. We cover a lot of this already as in these forecast talks, but it's always good to go back and look and refresh your memory a bit, especially as we get closer into the season and our summer heat goes away. We start to get to the time when the atmosphere is going to be changing. So overview of what I'll talk about today. We'll do a refresher on our three components of dispersion, our stability, mixing, and winds. touch on the morning allocation sheet and show an example of that. Then I added something different this time, kind of cut down on the basics since we've covered a lot of that this year. And I'm going to step through several days last year when we had a trough moving through and show how the atmosphere changed and our forecasting thought process on that, and highlight some terminology and some other things to watch out for in discussions for this season. And then a couple of links that I usually show towards the end there with wildfire webcams and whatnot. So we'll start with our famous rice burn graph here that I probably stole from one of you Western weather folks, however many years ago it's been. Boils down to atmospheric motion is what we're really talking about when we're talking about dispersion. So our horizontal or our vertical component of that is going to be stability and mixing, and our horizontal component will be wind. And you'll see us talk a lot about vertical motion and horizontal motion in our discussion sometimes. So these are the basic concepts behind that. Our standard atmosphere, as Kai alluded to earlier, colder above and warmer below. So as the sun heats the ground, that warm air is going to rise. So there's nothing in the way to block it. So this is what we want to see when it comes to dispersion and getting good burns, good plume rise, and all that kind of stuff. We want to see it colder aloft so that air can rise with the smoke particles and any other pollutants that are around. But what we often see is a stable atmosphere. And this is basically the exact opposite of what we want to see. We see warmer air aloft. We see colder air at the surface, and that acts like a lid on anything that is going to try and rise. So an inversion, the definition of the term, as a layer where the temperature increases with height, and that acts like our lid. And as it warms up down below, as the sun heats the ground and the surface temperature rises, the inversion will eventually go away. We use several terms for that: dissipating or mixing out, those kind of burning off. Those are all terms for the inversion going away by the afternoon. Mornings are most stable. Under a stable atmosphere, the air is going to sink and compress. So anything you try and burn below that is not going to go anywhere. And on this particular graph here, our stability calculation that we do is the temperature at 3,000 feet minus the surface temperature. So in this case, it was about 6 degrees, which really isn't a bad stability, just embellished a little bit for graph effect. Types of inversions, there are several different ways that these form. The most common one we see in the valley here is a radiation inversion, as the air cools at night and the warmer air lifts out. Under a high pressure center, we see a subsidence inversion as air sinks and compresses. If you're along the coast or in the far southern end of the valley in the Delta region, you may see the marine inversion. And then there's a frontal inversion as we get any type of cold front that'll come through. So we'll go over each of these here. A radiation inversion is when the ground cools at night, and so the warmer air that was there is going to lift out and form an inversion above that colder layer. So the temperature profile is on the left of this graph here, and it gets colder with height, and then it gets warmer with height, which is our inversion and our lid, and then above that it'll get colder with height again. So in a valley area, this is a pretty common feature, especially as we get later in the year and the nights get longer and the sun angle gets lower. In picture form, if you're in a mountain area, you'll often see this in the mornings, a big area of fog and low clouds hanging in the valley. So below that cloud layer there is very stable. So if you try and burn under that, your smoke's not going to lift. But if you're above that and you try and burn, then your smoke will probably lift out a little better. A marine inversion is when the ocean cooled air comes ashore, and in our case, it'll come in through the delta and up into the like Yolo and Sacramento, maybe even western Placer counties, and we'll have colder temperatures at the surface than we will further north. And as that colder air comes in, it'll push that warmer air up and out of the way, and you have an inversion formed by that warmer air that has been pushed up. And this leads to a pretty big difference in stability between north and south sometimes, which I think I have a slide about later. In picture form, here's some marine layer clouds coming in through a coastal valley. So again, if you're above that, you can see it's pretty clear and it looks a lot drier. So any burning that goes on above that is going to lift out pretty effectively. But below that, not so much. A frontal inversion, if you think of a cold front coming through, acts like a plow, and it plows up that warmer air out of the way. So above the cold front as it's coming through is a warmer air. So if you're trying to place burns during a day when we have a front coming through, number one, that's pretty tricky. Number two, you're going to have highly variable conditions as that front passes by. You could have a good lift ahead of that front, and then front goes by, your smoke could be trapped below the frontal inversion. That's not a common scenario that we deal with during our fall burn season, but it does happen. A subsidence inversion is usually an upper level inversion that's under a big high pressure center, typical or similar to what we've experienced in recent weeks and what we'll probably experience over the next week and a half or so. As high pressure remains anchored over an area, that air sinks and compresses and warms up. So even though your strong sun may be mixing the ground level, heating up the ground level and making that more unstable, you'll still have an inversion above that that's still going to trap everything a little bit higher. So now let's take a look at an unstable atmosphere, which is what we want to see. This is more like our standard idealized atmosphere where we have warm air at the surface and colder air aloft. So the air rises freely. We don't have anything to trap it or keep it under a certain level. Afternoons are going to be unstable, even when the morning inversion is strong. The afternoons can be more unstable as the ground heats up. However, especially as we get later in the season here, the inversion is going to reform as the ground cools off, as the sun starts to set. So after 3 o'clock or so, we start to see the sun starting to set, then that inversion is going to come back. It'll come back slowly, but if you still have smoke in the air later in the afternoon, we can have some issues as that inversion starts to develop again. In picture form, just look for the big puffy cumulus clouds, the vertically developed clouds. Those are a good sign that you have upward motion in the atmosphere, and upward motion is good for dispersion. It gets the smoke up and out. So if we kind of put this together now into our mixing section here, so everything below this inversion is going to be referred to as the mixed layer or the mixing layer. Mixing depth is another term we use for that. So everything below that inversion is the volume of atmosphere where your smoke is going to rise. And once it hits the inversion, it'll stop and it'll collect at that level, at that lid. So when we get temperature soundings in the morning, or we look at temperature soundings, we often look for where this inversion is going to set up and try and forecast the surface temperature so we can see when it'll actually erode or mix out. We look at 500 millibar heights, which is a level of the atmosphere about 18,000 feet up, where the pressure is 500 millibars. If we have a high pressure, referred to as a ridge, our air is sinking, compressing, and warming. So we have, clear skies, hot temperatures, light winds, everything that works against dispersion, basically. If we have a trough or a low pressure, that's where the 500 millibar heights are lower. So there's less of a thickness of air for the ground air to rise into. So the air rises and expands and cools. And low pressure troughs, especially later in the season, will bring precipitation and clouds. And the clouds could inhibit our mixing because they'll shade out the sun. 500 millibar heights are in our smoke management guidelines, Title 17, for our burn day declarations. And so a lot of air basins use 500 millibar heights for us to determine whether it's a permissive burn day or not. The pressure gradient force, we'll talk a lot about this as we start to get our offshore wind patterns later in the year. If the high and low are really close together and the lines of equal pressure, called isobars there, are packed really tight together, that's a good indicator that we're going to have some strong winds, especially if the high is really strong offshore and the low trough is moving by to our north and east. That's when we'll get those strong north wind days. So air is going to flow from the high to the low. So if you think of it like a topographic map, if you throw something off the top of the ridge, it's going to fall down into the valley. So I like to think about those as a topographic feature. Pressure, more thickness of the air, so the air is going to flow from the high into the low. So we put this all together into some common wind patterns we see here in the Sacramento Valley. We often see in the fall, and it seems like we're getting them more and more with each passing season, these north wind events, where we have wind coming from the north at a pretty good clip. And of course, that's going to carry anything smoke-wise down into Sacramento area and points further south, the more populated regions. Looking at these little plots here, these are called station plots. These wind barbs, so the arrow points or the barb points in the direction that the wind is coming from, and then the little flag ends there. The longer ones are 10 knots. And this is a pretty common north wind kind of surface map that we would see, 20 knots out of the north coming right down the valley. On the flip side of that, we have onshore flow through the delta. That flow comes up through the delta and kind of curves around the eastern side of the valley and comes up to the north there. So we get these southerly winds, southwesterly winds in the delta region, Sacramento area. Further north you go, it gets a little more easterly, southeasterly as you get further north. And that's the kind of weather pattern that we like to see, or the kind of wind pattern that we like to see for our burn program here in the fall. The north winds can often lead to restricted field days or no burn days. Usually exhibit a strong pressure gradient, so there's strong high pressure either offshore or to the northwest, and there's a trough that is either gone by or is passing by to our east. So we get the pressure gradient that sets up there, and the air is going to flow from the ridge to the trough. And this is, of course, problematic for our program because it burns all the smoke down to more populated areas. And a 500 millibar chart to show kind of what that looks like. Strong ridge offshore. 594 is a really high 500 millibar height, especially for the fall. It means we have a really thick air mass right there. And then a strong trough to the east, so the wind's going to try to follow how those lines go at 500 millibars. So just from a forecasting standpoint, pattern recognition of where the highs and lows are, this would tell me as a forecaster, looks like we're going to have north winds today. Southerly winds, usually ahead of an incoming trough, can exhibit a strong pressure gradient. Seems to me that the north winds have a stronger pressure gradient associated with those. But the south winds are more favorable for burning because it's going to blow things away from the populated areas in the south. But with south winds, you usually have a more unstable atmosphere as well because you have some kind of weather system coming in. The Schultz eddy is a wind pattern we get here in the valley that can sometimes lead to some unexpected results when it comes to smoke. During the day, when the wind comes in from the delta, comes up the valley, and spreads out just like the maps I was showing before. But then at night, when we get downslope flow out of the mountains in the valleys into the valley, then that can interact with this onshore flow, and we have this circulation that sets up around the Sutter Buttes. And so if you have burns going on the east side of the valley, and the circulation takes that smoke over to the west side of the valley, can move in some unexpected directions. Those wind flows are usually pretty light, so that it's not often that we see a whole lot of big impacts from that, but it's something to keep in mind if you're burning on the east side of the valley. You want to make sure that eddy's not going to catch your smoke if it's a bigger burn and carry it over to the west. So there's your weather patterns. Again, most of that has been discussed at length here in our previous training meetings that we've been having this year and in years past for the fall burn program here. We can move on now to our daily allocation sheet that we produce at CARB. A couple words about this first. It was in a HTML page for a long time, but now it is in PDF form, and you can access it through PFERS. I would imagine most folks on the call know how to get to it. But that's, I think, a little more friendly because you can save the PDF for each day if you're so inclined and go back and look. If there were impacts, you can see, what the morning numbers were or do some kind of research on that if you want. So the numbers that we, or the different terms that we've covered already, the stability, the 500 millibar height, winds, rainfall, and then our allocation equation that Kai was talking about earlier. Also, a number I didn't highlight on here is the PM, the average PM between 0 and 6, so midnight and 6 a.m. But these numbers, a 26 is most likely going to be a no burn day with that. That is a really high stability. That's an inversion that is, if it mixes out at all, it's going to take all day. 588 is a pretty high 500 millibar height for the date, which is October 22nd in this example. That's pretty late in the year to have a ridge that strong. So this is how, considering those previous factors in the previous slides with stability and the mixing and all that, that's how we come up with our numbers here for the morning. The PM 2.5 table is also definitely worth looking at. Whoops. Want to look at the yesterday's average between 0 and 6. And I like to look at yesterday's max and see who was either being affected by just, urban pollution, or if, the urban numbers are low, then you'll have the more rural area numbers will be higher. That would mean to me there's some kind of wildfire impact going on, or, it's not too terribly common that our fall burns affect these numbers. They'll make them a little elevated in some areas, but usually when we see the really high numbers for yesterday's max, it's due to wildfire, especially in recent years. You can also look at the hour of yesterday's maximum. That could tell you as well, if this hour is 2 a.m. and it's a really high number, then that would tell me maybe it's residential wood smoke that's causing that. If it's an afternoon number in an area that has a lot of rice burning going on, then that could be attributed, or that higher number could be attributed to that. So you can kind of deduce what's going on burn wise just from looking at that PM data there. And our discussion, which I will go over in great detail here in a few minutes, we tried to stay away from a lot of jargon if we can, but sometimes we don't really have a choice but to add that. In this one, some key terms here: strong morning inversions, breezy north winds. That's not good for our program. On the 24-hour outlook, we'll try and give a little dispersion outlook for the rest of the week, or the rest of the 7-day period here too. And we'll talk about some of that discussion here in a bit. And then our mixing heights and our winds. 2,000 for a mixing height is pretty common. Later in the year, we start to see more like 1,500 being a good one. But anything over 2,000, I think, is pretty good for a mixing height, especially for this time of year. The Sacramento Federal Ozone non-attainment area. If the ozone forecast is over 100, then for those zones in that table there, it will be a no burn day. As for ozone only. Or if Sac Metro issues a spare the air day, then those areas will be a no burn. So we see that in the summer quite a bit. I know under these big high pressure systems, and we'll probably see it this week when the ozone builds up. And then we have to do no burn days for those regions that are listed there. I meant to include a map with this, and of course I forgot. So that's our allocation sheet and a little bit about ozone non-attainment. What I want to do now is step through these several days here last year. This was the first decent trough that we had last year, and take you through some of the stuff we look at and explain some of the terminology that we put into our discussion. So this was late September. I think we had a little trough before this last year, but this was the first one that to me was more impressive. So we'll start with the ridge environment, the pre-storm environment on September 26th last year. Here's the 500 millibar chart for that morning. Trough that's going to eventually become our weather maker was off the coast of the Pacific Northwest. Big ridge over most of the western 2/3 of the nation. So from a forecasting standpoint, just looking at this, I think, okay, we've got a ridge, we've got a trough that's still offshore, so it's not going to really affect us yet. So our wind pattern's probably going to be upslope during the day, downslope at night, kind of that diurnal diurnal wind pattern that we usually see. Stability wise, if we look at APOBs, I should say a word about APOBs right now. We're not getting them at the moment, and we haven't been getting them for what seems like several months. The contracts ran out and they haven't renegotiated those yet, and some pilots have retired. So I'm very hopeful that we'll start to get those, but I don't know when that would be. But for argument's sake here, we'll look at APOBs for last year. On a weekend, we didn't get Red Bluff, which of course is the most important one for us in this program. But we can make an educated guess based on the one at Columbia, which is to our southeast in Tuolumne County. And on this particular morning, it showed that the atmosphere was a little bit cooler than the previous day. So the black line on this was the previous day's sounding. The red line is the current day's sounding. In the days before this, there was a string of no burn days as that ridge hung around. And this is pretty common for early in the burn season when we're coming out of summertime. We have summertime weather pattern with high pressure. We have no burn days, maybe some wildfire impacts, and people are getting a little itchy to burn. So these are these kind of transition periods we need to be careful with. But with this sounding here showing a pretty strong inversion, which Columbia typically does, but this is pretty strong even for them. So just looking at this, I know my morning atmosphere is pretty stable. It's a little bit cooler than yesterday, so the inversion may mix out a little faster, but it's still pretty strong inversion. We look at the Oakland sounding as well for another idea about how our inversions are behaving. Oakland sounding shows a pretty strong inversion. Yeah, this would be the marine layer, the marine inversion. It's about 2,000 feet deep, maybe a little more than that. Also see some onshore flow, some decent onshore flow at about 3,000 feet up. It's 30 knots out of the west and southwest, so that's pretty good onshore flow. Just go right back to that. So I also like to look not just at the vertical temperature profile, but also the dew point, which is the line to the left, and then our wind profile too. This tells us a lot, especially when we have north wind scenario developing. This vertical wind profile will tell us a lot. This is just the wind speed and direction at each level that this balloon sounding measures. So if we go to our allocation sheet, our stability, 16, that's pretty high. That's not uncommon to see a number that high. And if you remember back to one of Kai's slides about the stability for our program when it comes to no burn days and stuff, 17 is kind of that magic number. So this is getting close to that. Our 500 millibar height's pretty high, 586. Although for September, that's not anything outlandish, but it's still pretty high. Wind speed's pretty good, 10. I like to see an 8 to 12 kind of things to call it a good wind. That's not any hard and fast term, but that's what I like to see. PM's pretty low. And then our allocation of 2,000 acres. But pay attention here to the PM 2.5 data is pretty high the day before this. And some of it was at midnight, and some of it was in the morning and in the early afternoon. Or that's actually late afternoon, but definitely in the morning hours. And this was mainly wildfire smoke. But our average from the previous day was also, pretty up there. So we like to watch those air quality trends as well as the trends in all the rest of our data. Move over to our discussion. Not much change from yesterday, meaning, persistence, what you see is what you get. Talk about ramped up delta breeze means our onshore flow is starting to turn. So that's going to be better for scouring us out eventually. And then in our extended discussion, we say that delta breeze pattern is going to continue. So that's good for us. Later in the forecast period, so later in the week, we'll start to see that pattern go away, and we'll start to see those inversions kick back in. And then big change expected as north winds build in. So we're trying to give you a heads up, on any changes in the pattern that could be, either good or bad. We want you to know about those ahead of time. Our mixing heights, pretty good number there, 2,500 feet. And then our winds, if you see a south wind gusting like that, it's pretty good for dispersion for us. The next day is when the trough finally started to move in. 500 millibar chart from this day shows the trough still offshore, but closer. Whoops. Our ridge, I didn't mark it, but our ridge has moved off to the east a bit. So just looking at this chart as a forecaster, I recognize this pattern as probably southerly winds developing, better burn day, probably lower stability. So we got the red bluff sounding that morning. We can see from that we do have some inversions in place, nothing too bad. So it'll probably mix out pretty quick. At Columbia, just looking at that one again, the overall temperature profile is quite a bit cooler. And the inversion is weaker, but it's still round. So it's still, below 1,000 feet, still pretty strong inversion, but not as bad as the previous day. The Oakland sounding shows something similar. Our inversion is a bit weaker. The lower part of the temperature profile down there at the very bottom is also a lot more humid. So our temperature and dew point are pretty much the same. So that would tell me, onshore flow, marine layer coming in. Our wind profile, more uniform onshore flow at all levels. Nothing terribly strong, but definitely trending in the right direction. We look at our allocation sheet. Our stability's come down, which is good. Our 500 millibar heights are still up there. Our winds are still good, and our PMs have actually come down. So whatever onshore flow we had the previous day has acted to move some of the smoke and haze out. And one elevated number, Glenn County there, in mid-afternoon time. So probably some wildfire smoke impacts. Everybody else's numbers were way down from the day previous to that. So as a forecaster, it tells me we're trending in the right direction as far as burn day goes. We say permissive burn day for this one. Next weather system is on track. So just a heads up that we got a change in the weather coming. Increasing onshore flow, which is good. Increasing clouds, which may inhibit mixing a bit. So all those kind of things you want to look for. Ridge coming back quickly after this trough goes by. So that's a headline we would want to highlight, which usually will bring us some north winds. So we want to make sure and note that ahead of time. And again, with the light terrain-driven winds out beyond as the ridge builds in. So our mixing heights are good, as we would expect with an incoming trough, and our winds are still good, as we would expect with this pattern too. So overall, a decent burn day, but due to some lingering wildfire smoke and not quite sure when the front would come through, we kept it at 2,000. This is the kind of day as well that if things improve a little more quickly than we think, you can request extra acreage. So the trough goes by the following day, September 28th. So this is when our trough is overhead and to the east. Our ridge is well out into the plains in the Midwest. So our north wind pattern is definitely developing as this trough goes by. Stability-wise, looking really good on a atmosphere like this. When the profile is straight up or bends to the left, that's a good unstable atmosphere. Still got a little inversion, but it should be quick to go away. Temperature profile is cooler at Columbia as well, much cooler, and really no change with height there. A term called isothermal, no change in temperature. So that'll become unstable pretty quickly as the ground heats up. So mixing wise, looks like we're going to be pretty good. We look at Oakland sounding, we can already see some changes that are going on in Oakland. Our inversion is still pretty weak, but also the temperature profile down below that is much drier. So down at the bottom there's our temperature profile, and the dew point is to the left, and that's a pretty big gap there, so that's drying out, which would tell me that some north winds are starting to push in. And that is borne out by looking at the winds. We have north to northwest flow. And then if you look even higher, we have really strong winds aloft. So these the triangle on these wind barbs here is 50 knots. So as you go up, you have 50, 70, 80 knot winds. And that's important because if those upper winds are really strong too, that'll support gusty north winds at the surface. Looking at our allocation sheet, stability, anytime you see a stability with a negative number, you're in really good shape. So that's an unstable atmosphere. 500 millibar height is lower. 567 is a good number. Our winds, we need to keep in mind that we don't have a wind direction on this little table up here yet. So we need to consider that could be a north wind. Our PMs are low still, but our acreage allocation is 0 today because we have north winds, and the north winds are over 20. So that triggers a no burn day for this program. Some terms to highlight in the discussion: active north and northwest winds, red flag warnings, some pretty high speeds there. And the north and west sides of the valley are usually the windiest. As we look forward into the next week, still talking about the light terrain-driven winds coming back as high pressure builds in. Mixing heights reaching 3,000 feet, and the winds are strong, but from the wrong direction. So that's not a good wind for our program. The north at 15. As we get one more day out, this is the last day that I did here. This was a north wind day where our trough is to the east. Our ridge is farther to the east, and we have another ridge building in from the Pacific right there. Also note that all the winds in California at this 500 millibar level are coming from the northwest. So that tells me that there's lots of upper level support for gusty north winds in the valley. Looking at our sounding, our temperature profile is actually warmed up since the previous day, and that's probably due to north winds being active overnight at Red Bluff. Red Bluff seems to be in an area where that compressional warming is that effect is strongest as the winds come down out of Shasta County and really compressional warm right there at Red Bluff. We got our inversions that are reforming. So this, especially the one that's a little further aloft would tell me that high pressure is definitely building in. We look at Oakland, our lower levels are pretty dry still, which tells me that north wind is kicking in there. Stronger inversion, it's a deeper inversion. So instead of going up off the deck and slowly coming back, it actually increases with height for quite a distance as you go up. Look at our wind profile, it's really strong all the way up. So lots of upper level support for gusty north winds at the surface. Our allocation sheet is going to reflect that. Higher stability this morning, 500 millibar height's gone up some. Winds, 15 is a trigger number for restricted field day. PMs are still pretty low, and 2,000 is our allocation. When you get these gusty wind episodes, the PM 2.5 levels seem to remain in check for the most part, but some areas do get elevated PM 10 with the blowing dust. Moving on to our discussion here. Again, restricted field day, gusty north winds. Trough has moved east into the Great Basin, so that's our north wind pattern. And then he goes on to discuss the different wind speeds there. As we look into the later on discussion, high pressure is going to build in, flow becomes weak, temperatures warm up. So as a smoke management person, that would tell you that dispersion is going to deteriorate with time. Mixing height's still really good. Our winds are still, from the north, wrong direction. For our program, we like to see southerlies, not northerlies. So that was a step through our forecast process for the day. Most of those days were done by one forecaster. This one was done by another. So we try and keep that consistency going as we go through time. A couple more slides on our tools and resources, all of our links that we usually show here. I'll put a plug in for PFERS. A couple notes about PFERS. There aren't any big changes to PFERS this year, but as some folks are probably aware, we're going to do a major upgrade of the system as we get through the next year or two, and make it more user-friendly and hopefully more consistent when it comes to data collection and reporting. So stay tuned for that. That's going to be a process, but a long-needed process. The high-resolution rapid refresh smoke model is a good one to look at in conjunction with Blue Sky, which I'm sure most folks on the call here are familiar with, and then the California Smoke Blog. Couple others, the Alert Wildfire webcams, as Kai alluded to earlier. And this year we have GOES 18, our high-resolution satellite. Can find that in a couple spots, and there's probably even more that I didn't put on here, but that's really good high-resolution satellite imagery. I was looking at it yesterday, and you could see all the little features that we're that were in place. And of course, our National Weather Service offices. The Sacramento Valley is covered mainly by the Sacramento office. As you get east, you're in Reno. As you get west, you're in either the Bay Area or Eureka. And that is end of my report. Questions, comments, complaints?
Let's go ahead and switch over to our dashboard. Okay, hopefully that is nice and easy to see. I'll make that a little bit bigger. Okay, so this is the dashboard where you can view all the Western weather stuff. So first of all, if you do not have access to this or you've never seen it before, definitely let me know. You can hang out after or send me an email and we can get you access to this. But I'll just sort of do a nice top-down approach. So the first things at the top here are all the forecast links. We have that early morning forecast that comes out at 5:45. More general of a forecast, so nothing super fall burn intensive yet, but still a good way to look at it. You have your 8 a.m., 9 a.m., and 11 a.m. files all up here ready to go. Also up here, there is the daily reporting form, which I'll go through in just a minute. It looks like this, and I'll show you how to fill it out. Also on here, we have all of our weather data available. So let's look at these maps first. These are all of our stations Western Weather Group manages through the valley floor. So you can see there are a ton of them. This is a great way to check out what the wind conditions are doing. You can click on this drop-down menu up here in the upper right, be able to look at what the wind speeds are exactly, or the wind gusts, or just the temperature, anything you can think of. We should have available right there. Some important stations to note, of course, ones that are closest to you. Learn which ones those are and find them quickly. We have our Sutter Butte station right here, along with Pennington. Those are the ones we look at for the inversion strength. Over here on the right, we have PG&E foothill stations. So none of these are really on the, or very few of them are on the valley floor. Most of them are in slightly higher elevations. So if you want to see what the wind pattern is like at some slightly higher elevations, or if perhaps you're doing a prescribed burn up there, this is a great way to look at all of those. You can see we don't have a lot of agricultural stations in Shasta County and a lot of Tehama County as well, but a lot of these PG&E stations start to intersect there as well. So if you're in those northern counties, it's a really good resource over here. So that's a great way to check your current weather conditions. There's also a nice little refresh button on both of these maps, so you don't have to refresh the whole page. Next, we have our inversion graph, so we can see the Pennington temperature versus the Sutter Buttes temperature. So we can actually follow the inversion here. We can see the Sutter Buttes hanging out in the 70s all night and through the morning, versus if we follow Pennington, you can see it's nice and hot during the day, it cools off rapidly at night, and at this point, it's now colder at our lower elevation than up high, so we're inverted. And right here at about 10 o'clock yesterday, Pennington got hotter and the inversion broke. And it stayed unstable for the rest of the day until we started to come back to that. So that's the daily pattern you'll see. You can the important thing to watch here is you can check out when the inversion has been breaking as of late. Next, we have our detailed weather data by county. One of my coworkers has been working hard to get all of this nice and updated. So if you need to look at some tabular data and start to look at some averages throughout your county, this is a really great way to do that. So just tons of numbers here to see what the weather conditions are doing. And there's some more resources down here. We have the zone map, which is available. This was just redone this year. It's a much more high resolution and I think a lot easier to read than our last one. So very happy with how this turned out. Another good resource. We also have that in a Google Earth version. I can't upload it for whatever reason, but if you'd like it, I can email it to you. There's a bunch of stuff to check out here. I recommend clicking around to sort of see how things are going. Those alert wildfire webcams I'll show off very briefly. What you do is you sort of click on the region you're close to. A lot of the stuff's going to be here in this Shasta region. And if this loads okay, oh, come on. Man, I don't think I've ever seen the site slow down like this. I guess I'll circle back to this and hope it loads in okay. Anyway, those are great resources for checking out some real-time video of how some smoke plumes are rising. Down here we have some tutorial videos. We have last year's training session video. We have how to submit program files and how to set up alarms too. So that's all very helpful. We have a lot of ARB links over here. I may need to update some of them, but I think most of this should be good to go still. Yeah. A new feature I added for you history buffs are the program summary reports all the way back to 2002. I think I'm missing 2001 here. Yeah, but we can see those if we click on them. Oh, wasn't that let? Well, I might need to troubleshoot that, but okay, here 2017 is working. So this has some old information if you'd like to go back in time. Okay, so that's a quick overview of the dashboard. Again, if you don't have access to this, definitely let me know. And also, if you know you're not signed up to receive the emails for these forecasts, definitely let me know as well, and we can get everything taken care of before we start. We'll also have a link to the 9:30 conference call on this page. Right now, this is the old link. I'll get it fixed with the new one before the season starts. All right, well, unfortunately, Alert Wildfire seems to be having some issues. So, okay, well, for whatever reason, Montana's working. Can I just get one more? Okay, so this is the wrong area, but this is essentially what they look like. They're cameras that overlook the valleys, and you can see how your smoke plumes are behaving when you start to perform those burns. You want to see that nice lift and good dispersion aloft. Okay, last thing to talk about is the daily reporting form. This is where you will report how much acreage you burned yesterday. So we can just pretend the fall burn program is active right now. What I do is, so yesterday would be the 29th. Let's say I'm in Butte County. Let's see, already acres. Let's just say there's like 5,000. And then for how much we burned, let's say we just burned a solid 200 acres in zone 1. We go down to the types burned, and it was all rice. You can see you have all your other types that you need to report here. Total acres burned, again, that's 200, and we got no complaints. And I'll just go ahead and write test down here for now. If you'd like, you can do the remember my email and county for next time, and then you just go ahead and hit submit. That's all you need to do. So very important, something I forgot to mention during my primary presentation is that even if you burn nothing, you still need to report this. So just fill everything out as 0, scroll down to the bottom and hit submit. So it'll only take you 5 seconds or so, and it saves a lot of trouble of me having to bother you later for days that we didn't get a file. So even if it's 0, just go ahead and hit 0 on everything and hit submit. Okay, are there any questions about the dashboard or the reporting form from anyone? Okay, hearing none, I say that we are done with our training session for today. Thank you all very much for coming. If there's any final questions, you're welcome to stick around. And if not, have a great rest of your day, and thanks again.